Hello everyone, in this video we are going to talk about how do we name the ionic compounds, right? So let's start. Now each name, every name has a first name and a last name, right? So same is applicable for all the compounds. All the ionic compounds have a first name and the last name. First name comes from the cation, name of the cation, and the last name is the name of the anion, right? So first step is you have to identify the metal and the non-metal in the name. So first name is always the metal and the last name is always the non-metal anion. Anions are formed by non-metals, don't forget that, and cations are formed by the metals, and the compound formed by the electrostatic attraction between a cation and anion is what we call an ionic compound, right? So let's see few examples. Now always remember, monatomic anions always end in IDE, right? That's their name. It always ends in IDE, like oxide, sulfide, chloride, nitride, phosphide, and so on. Whereas polyatomic anions, there's no other way. You have to memorize the list that I gave you, right? You already have started memorizing your polyatomic anions. Okay. Now let's try to name these ionic compounds. So first of all, identify the cation and anion and the anion. Remember, the first name is always name of the cation, right? So identify the metal. So this is the metal. So this is the metal. K is the metal. And then Cl is the non-metal, right? So cation will be formed by potassium and anion would be formed by non-metal, right? Chlorine. So how would we name this element, name this ionic compound? The name of the cation, so that is potassium, and the last name is the name of the anion. Now what kind of anion chlorine will make? It's a monatomic ion, right? Chlorine always makes Cl1 minus. So that is what we call chloride ion, right? So potassium, then chloride. Name of the cation and the name of the anion. This is how we name this element, right? So let's figure out the metal in this one. Potassium is the metal, so this is the metal, and this whole thing is a polyatomic anion, right? So that is polyatomic anion. Anion is always formed by the non-metals. You can see P and oxygen both are non-metals. So we just kind of separated the metal, rest everything is the anion, right? So just take out the metal. So name would start with the cation, which is always the metal. So we're gonna write potassium again, potassium. And now this anion, you need to memorize its name. What kind of anion is this? PO4 is phosphate, right? So this is potassium phosphate. Cation and end with the anion. So this is the anion and this part is the cation, right? Now let's do this one. So identify the metal. Again, it's potassium. So potassium is the metal, and then rest whole of the thing is the polyatomic anion. right? So that would be potassium. This is a carbonate ion, right? Potassium carbonate. You need to memorize your ions. Okay. Now let's identify the metal. In this case, metal is magnesium. This is the metal and fluorine is the non-metal, right? So the name would be, start with the name of the cation, magnesium, and then end with the name of the anion. Since it's a monatomic anion, the name of the ion formed by fluorine is fluoride. So magnesium fluoride, right? Now let's see how do we name the metals with variable charges, right? Remember the D block and some of the metals in the P block, they make multiple cations with variable charges or variable oxidation states. So we have to use the Roman numerals in the metal name, right? Now first we are going to repeat the same step, right? So first identify the metal. So metal is the lead and the non-metal, so this is the metal, right? Just isolate the metal and you would, rest everything would be the anion, right? So this is the cation, this is the anion. Now since it has a charge of 2 plus, right? I will tell you how do we calculate, how do we find out what charge of the cation is, right? For now, this is the cation that makes this compound, right? So this is the cation, so that would be lead. Now the charge, since lead makes two different types of cations, 2 plus and 4 plus. So this is 2 plus. This compound contains lead 2. So this charge, how did I know this? Look at the subscript of chlorine. This is the charge of lead. I'll tell you why, right? So this is lead 2 and then the name of the anion, which is chloride. So the name of this compound would be lead 2 chloride, right? Now we have another compound, Cu and Cl. The metal is this is the metal and this is a D block metal, right? Now look at the subscript of chlorine. There's no subscript, right? It means the charge, if there is no subscript, it still means 1, right? So this subscript comes from the charge on the metal atom, right? So since it is 1, copper will have a charge of 1 plus, right? So this is the metal. So how do we name this compound? Name of the metal, which is copper. Since it's a D block and it makes multiple cations, right? And it's not one of those exceptions. So there are 3 metals, silver, zinc and cadmium. If it was one of those 3, then we would not have used the Roman numerals. But it's not any of those 3 metals, so we have to use the Roman numeral to specify the charge on the metal ion. So copper 1, because that's the charge, chloride. Let's see another example. So we have iron metal. So this is the metal. Isolate the metal. We always start with metal name. So that is iron. Now how do I know what kind of charge would iron metal make when making the ionic compound? Now look at the subscript on the OH, right? This is a polyatomic anion that you need to memorize. So this 3 kind of comes from the metal. So this is the charge on the metal. So I can write iron 3 plus, and then we have hydroxide ion that has a charge of 1 minus, right? So iron has a charge of 3 plus, so I will write iron 3, then the name of the anion, which is hydroxide. So iron 3 hydroxide is the name of this compound, right? So this is where I have told you how to work your charge backwards, right? Always look at the subscript. So now if I ask you name this compound PbCl2, I don't know what the charge on the metal Pb is. So first of all I have to isolate the metal. So this is the metal. Now look at the subscript on the anion. So that too kind of comes from the metal. Always remember, metals always make cation. So it has to be a positive charge. So that too is the charge of the metal atom, and it would be always +2, right? So lead has a charge of 2+, and chloride I kind of already know from the periodic table, that's always 1-, right? And now how do we make a formula? So we do the crisscross. So this charge becomes the subscript of the charge on the anion, and this becomes the subscript of the charge on the cation, right? So the formula kind of becomes like this, PbCl2, right? The subscript on the anion comes from the cation. This one comes from the anion, and the subscript on the anion comes from the cation, right? The one on the cation comes from the anion. We kind of do the crisscross like this, right? So this charge becomes the subscript on the anion. So this is the cation, this is the anion. Subscript on the anion comes from the cation, and the subscript on the cation comes from the anion, right? So now the whole crisscross thing is to neutralize the charges, right? So if you look at PbCl2, it means we have 1 ion of Pb and 2 ions of Cl. The single lead ion has +2 charge, so it has 2 positive charges, right? And each of the chlorine has 1 negative charge, so 2 negative charges. 2 positive charges are balanced by 2 negative charges, right? And the compound is electrically neutral. So this is a neutral compound, right? All the ionic compounds are always neutral because the positive charges and the negative charges are always balanced, right? The charges are always balanced. They should always be balanced, otherwise it's not a neutral compound. It will still be an ion. Okay, so let's do some examples. So I have taken this example. Now let's see. So we have Ni3N2, and you have to name this compound, right? Now first of all, identify the metal. The metal is nickel, and it will form a cation, right? When you isolate the metal, everything that is left is the anion, right? So the non-metal part is nitrogen, and that will make an ion. I can always tell what kind of ion would nitrogen make from the periodic table. I can tell it is N3(1-), right? So I kind of know the anion made by nitrogen. So this is N3, which we call nitride ion, right? I know nickel is going to make some kind of charge, but since nickel is right here on the periodic table, it's in the D block, I don't know what kind of charge would nickel make. So in order to name the compounds, ionic compounds formed from the D block elements, I need to specify the charge. I need to know the charge on nickel. Okay. So what kind of charge would nickel make? So I can undo the crisscross. So look, in the formula we have a subscript on the nitrogen, that is 2. So that subscript kind of comes from the nickel. So we have Ni and then we have N3 negative. Now this subscript, that 2, is coming from nickel. So we can undo the crisscross. So this 2 can be made as a charge on nickel, right? So that becomes nickel 2 plus. So this 2 is the charge coming from the nickel, right? So I can write nickel is 2 plus, right? Now we have these two. Let's check if we get the same formula or not, right? So we have these two ions, nickel 2 plus. How did I figure out the charge? From the subscript of the anion, and nitrogen has a charge of 3 minus. So now what we do is we do a crisscross. Take this charge and make it as a subscript of nitrogen. So this 2 comes here, and take the charge, only the numerical value of the charge we need. We do not need plus and minus. Take this 3, the charge value of nitrogen, and make it a subscript on nickel, right? And now we have 3 nickel atoms, ions, and N has a subscript of 2, so N2. This is exactly the formula that we have here, right? So we always have to do the crisscross thing. Take the charge on the cation charge, and make it as a subscript on anion, right? Take the charge on the anion and make it as a subscript on cation. So this is how we write down the neutral formula for the compounds, right? So now we know the charge. Nickel has a 2 plus and nitride ion. So we will name this compound nickel 2 because the charge is 2 plus nitride, nickel 2 nitride, right? So in the formula you can see we have 3 nickel ions and 2 nitrogen ions. So I have drawn this to show you how the charges are balanced. So nickel 2 plus, we have 3 of those, 3 of the nickel 2 pluses, 1, 2 and 3. So a total charge of plus 2, plus 2, plus 2, a total charge of plus 6. And look at the nitride charges, negative 3, so 3 negative, a total charge of negative 6. So negative 6 is balanced by positive 6. So both the charges are balanced. So that is why Ni3N2 is a neutral compound. Ionic compounds are always neutral. So ionic compounds are always neutral, always neutral. All the negative charges have to be balanced by the positive charges, right? Ionic compound is always neutral, right? Let's do another example and see if that makes sense. So first of all, let's write down the formula for nitrate. Right? So given the name, and if you're asked to write down the formula of the compound, how do we do that? So first of all, the metal is potassium. What kind of charge would potassium make? What kind of ion? Potassium is in group 1, right? So I know it is going to make +1 ion. So let's write down the ion formed by potassium. And then the anion part, you need to know the name of the anion and write its formula. Nitrate is NO3 1-. So we always put a parenthesis for the polyatomic anions, right? So these are the two ions, right? Now how do we write down the formula of a neutral compound? So always do the crisscross. So potassium has a charge of 1+ and nitrate has a charge of 1-, right? So take this numerical value, and so let's write down K and then NO3, right? So these are the two ions. So take this numerical value and make it as a subscript on the nitrate. Take the numerical value, so this is 1, so we can write 1 here. Take the numerical value of the charge on the nitrate and make it as a subscript here, so 1. So 1 and 1. We usually do not write 1, so our formula becomes KNO3, right? So let's do another example. Let us write down the name of copper 2 oxide. Now copper 2, so we kind of know the charge on the copper metal, right? So copper 2 means copper 2+, because metals always make cations. And what kind of charge would oxygen make? What kind of ion? Oxygen is in group 16, right? So they always make 2 negative ions. So we have an oxide ion. The formula of oxide ion is 2 negative, right? Now let's do the crisscross thing, right? So this charge value of copper becomes the subscript of oxygen, and this charge value on oxide ion becomes the subscript of copper. So we kind of have Cu2O2, right? Now whenever you have the same subscripts, so it's kind of ratio 2:2, right? We can always simplify this ratio. So this can be 1:1, right? So we can write the formula of copper 2 oxide as a simplified ratio, which we can write CuO. So this is the right formula. Always reduce the ratio. Always use reduced ratio to write the formula. The neutral formula. Even if you do the crisscross thing and you get this ratio, right? Don't forget to reduce the ratio. So this is the formula for copper 2 oxide. Let's do another example. Write down the formula for magnesium phosphate. Now I know magnesium is group 2 and it will always make Mg2+, right? Remember, there is no Roman numerals, so it means it's not a D block element, right? Or not a transition metal. So magnesium only makes one kind of ion. So magnesium will make 2+, and the formula for phosphate is PO4 3 negative. You have to memorize this, right? Now let's do the crisscross thing to write down the neutral compound. So this 2, the numerical value of the charge on magnesium, becomes the subscript on phosphate. Always use parentheses. And this charge value of the phosphate becomes the subscript on magnesium. So we have this formula Mg2, then phosphate is PO4 in parentheses, and now this is 3, right? Mg3. So this 3 goes here and this 2 goes here. So that is the formula for magnesium phosphate. Mg3 in parentheses PO4 and then 2, right? You can actually see we have 3 magnesium ions and each magnesium ion has a charge of 2+. We have 3 of those. So subscript tells you how many ions do we have. So this subscript 3 means we have 3 magnesium ions. So each magnesium ion has a charge of 2+. So 2 plus 2 plus 2, total of 6 positive charges, right? And now we have 2 phosphates. So each of the phosphate ion has a charge of 3-. So we have 2 of those, right? -3 is -6. So these are balanced, right? So they are balanced, and hence we have a neutral formula for magnesium phosphate. Okay. So now let's do some more examples. Writing neutral formulas. Maybe we can do that example in the next video.